The other factor number 5, is a catalyst that will, influence the rate of a chemical reaction. Now, when we talk about a catalyst is any substance that alters the rate of a chemical reaction. So this is what I'm saying. But now we have a question that we need to answer here. When we say that catalysts alter the rate of chemical reactions, we need to explain how do they alter these rates. Now, catalysts will alter the rate of chemical reactions by lowering the activation energy. Now, I want you to remember about the activation energy. We said that for any chemical reaction to progress or to start, there must be energy that is applied, to overcome a barrier. You remember when I drew the energy level diagram to show you the activation energy, I had shown you something that looks like a barrier. For example, this one here. This is the axis for the energy. This shows the energy. And this one shows the reaction path. Then this hill here, you can see this hill. This one here, it's a barrier. And we said this one here is the one that represents the activation energy, if you can recall clearly. Now, for any chemical reaction to start and progress, that activation energy must be overcome, or that activation energy must be supplied. Now, what happens is that when we use catalysts, they lower the activation energy. How? I want to show you this. Let me use a larger diagram on this side here. Okay. Now, of course, we have the products here. So we have the products there. Okay. So this one is the activation energy. You can call it hill or you call it barrier, so that you remember it. Definition of activation energy will still stand. Don't say, when you're asked to define activation energy, don't say it is a barrier or it's a hill. Okay. Now, this energy level diagram shows a reaction whereby there is no catalyst. So this one is uncatalyzed. So I can say this hill here is showing uncatalyzed reaction. If we apply a catalyst now in this reaction, we put a catalyst, this is now what will happen. This activation energy will be lowered. So we will have something that looks like this. Smaller activation energy. We'll have it there. Now, that means this smaller hill here represents a catalyzed process. Now, you can see now from this diagram that a catalyst alters the rate of a chemical reaction by lowering the activation energy. So this activation energy is already lowered. I hope you can see that one now from your end. You can get a diagram in any exam that looks like this, and then you are told to explain the diagram, or you are told to label which one of these hills represents a catalyzed process or represents a catalyzed reaction. I want to give you one example of a chemical reaction where a catalyst is used. Now, this is a reaction that is learned in Form 3. So this is about a process we call conduct process. Now, conduct process is an industrial process of the manufacture of sulfuric 6 acid. Now, remember, in the process, we need to oxidize sulfur 4 oxide in the presence of a catalyst. I want you to know that in the absence of a catalyst, sulfur 4 oxide cannot take any more oxygen by itself. There must be a catalyst here for this reaction to take place. So this is an example of an industrial process where a catalyst is used to reduce the activation energy for the reaction to take place. So I also want you to get other examples whereby a catalyst is used to reduce the activation energy and maximize the yield. Then you share that particular assignment with me on WhatsApp.